Hey everyone, welcome back. So today we're going to talk about pedigrees. So if you go to Schoology quarter 4 week 2, there's a pedigree notes worksheet that we're going to complete together. So this is what this is. I've already uploaded it into OneNote for myself. And we're going to kind of walk through the first 8 of these together, be able to get an understanding of what's going on, and then you guys will finish the last half today in class. So pedigrees are basically what we did with your probability squares, also known as Punnett squares, but we looked at the probability of the math behind it. So when we did pedigrees, it would make a lot more sense. And what basically they show is our probability squares, but over multiple generations, without maybe knowing specifically the genotypes, but at least knowing the phenotypes. And so that's what's going to show us. So we saw this on case, but we didn't really get to this point before case. So you may or may not have known what was going on. But as we talk through this, it should make more sense and kind of click about what you saw. So the first thing we're going to look at is the key specifically. So a square is unaffected male, a circle is unaffected female. If it's not filled in, it's going to be unaffected of that trait. That could be a dominant trait, recessive trait, that could be a disease, that could be hair color, eye color, whatever that looks like. A fully shaded square is an affected male of that trait that we're looking at. A shaded circle is an affected female, while a carrier male is half shaded and a carrier female is half shaded. So what I mean by half shaded is this. Now, however, with carriers, we also saw them as heterozygous because they have a allele for a trait that is not shown in the phenotype. So this lowercase would be the carrier. Now, the other thing about this is when we look at it, we don't always know what the carriers are. So sometimes they are labeled as carriers and sometimes they're not. So we just kind of make sure that you know what it looks like just in case they ever give it to you. So we're going to first draw how a couple is married on a pedigree. So we have square male with a line to a circle female, and that's going to be that example. And we have a couple who's married who has children. So we're going to do the same thing, couple, and then we're going to draw a line from that union line and have children. So right here would be the offspring, or known as the children. Okay. Now, if we look at this one specifically, we can look at generations. So the parents here would be generation 1, the offspring would be generation 2. You may see that, you may not. Just kind of depends on what type of question they throw at you. Now we're going to draw a pedigree that represents Mary, married to Greg, with 2 sons. So we have Mary. I'm going to erase that. So if ever it tells you age, we do age to the left for the oldest and youngest to the right. If not, we go by the order it tells us, unless you get to a problem later that talks about, hey, well, this brother, then you just throw it in there where you need to. He's married to Greg with 2 sons. So we have Scott, Tyler, and Karen. So that would be a 2-generational pedigree, like so. Now we're going to draw Mary with Greg. With Scott, that's way too big. Tyler and Karen. And then it says Scott is married to April. So see how April here is not bound to Mary and Greg, but they're still in union with Scott. That is how we draw when somebody's married. That's not in that family. So there's Sutton and there's Kendall. And then Karen married Harry. And they had 2 sons, Alik and Tariq. That should be a square. All right, so now we're going to draw a pedigree that represents Julia marries Jeff with one daughter, Josephine, which is married to Joseph. They had Jason and Joe. Joe married Julia, who had Sharon and two fraternal twin boys. So that's twins, that's fraternal. Mark, Alex. Mark married Allison, which had Ray and Scarlett. So we have generation 1, 2, 3, 4, and 5. Okay. All right. So now we're going to skip to while we're doing what we're doing. So within this, what we are going to do is we're going to look at autosomal, X-linked, recessive, and dominant traits. So recessive are the lowercase letters, and the big look for is that you're going to skip a generation. So for instance, looking at number 6, both parents do not have the trait, however, it shows up in the offspring. That would be an example of skipping a generation. While dominant is going to show up in every generation. So we have those. Now we're going to look at autosomal and X-linked. So there's a couple look fors, and they don't always do it 100%. So first off, X-linked is not going to be dominant. So not dominant. Okay. The other thing within this is that they're going to be more males than females, usually 2 times the amount of number of males than females. And so what we look at is the reason for that is, let's say it's a recessive trait. Dad would be this one. He doesn't have it. Mom is heterozygous. The only possible combinations for sons would be X capital N, Y, which means they wouldn't have the trait, and X lowercase n, Y, which means they would have the trait. So there's a 50-50 shot, while the females would not because of Dad's capital N there. And so X-linked is going to be found on the 23rd pair of the chromosome, while autosomal is 1 through 22, and it's going to follow the normal passing of traits, that dominant, recessive, homozygous, heterozygous passing. So we're going to do these together and kind of talk you through some things. So is this autosomal or X-linked? Is it dominant, recessive? Please explain. Now, the first thing we're going to say, it is recessive. That's the easiest one. Whether it be dominant or recessive, you know that. While though autosomal X-linked, because it's only 2 generations, here and here, it's very, very hard to find a pattern. So let's just kind of like look at it within an autosomal standpoint. So these could be heterozygous, which give an explanation of why these two show the recessive traits and these two show the dominant trait. Okay, so it could be autosomal, and because there's only 2 generations, there's not really a best one. Okay, when I give you one on a test, then it'll be like 3 or 4 generations big. Okay, so now let's look to see if this would be X-linked. So this is a great way to explain X-linked if it is or not. So X-linked, because it is recessive, would have to be, this one would have to be a capital N for the male, while mom would have to be capital N lowercase n. There is a good chance that both of these males could be this, while these males could either be homozygous dominant, or these 2 females could be either homozygous dominant or heterozygous dominant. And because there are 2 males here, it could also be X-linked. And so a great way to know whether it be autosomal or X-linked is if this shows up and this works out to be able to produce this offspring, then there's a good chance that it's going to show that, okay, or be X-linked. Now, is the following X-linked or autosomal, dominant or recessive? So it shows up in every generation, so it's going to be dominant. And in this case, there are 4 females to 3 males. There's not really X-linked. There's not X-linked dominant, so this is going to be autosomal. Okay. So now, is this following either autosomal or X-linked? Is it dominant or recessive? So it skips a generation, looking here. This is going to be recessive. So now we got to decide, is it X-linked or autosomal? So within this, let's look at specifically this generation here. Okay, so mom is going to be, since it's recessive, is going to have to be heterozygous. So XN, X lowercase n, while dad is X lowercase n. So the possible combinations for offspring for females, or possible combination for males is, and that possibly could work, okay? And so within this one, it could be recessive, or no, it is recessive, but it could be X-linked. So then let's try another one just to make sure. Let's look at this one. So mom would be X capital N, X lowercase n, while dad would be X capital N, Y. Females could be that, and that does not make sense because of that female right there having the recessive trait, so it has to be autosomal. Okay, so you always test the X-link first. If it doesn't meet the requirement there, then you would go with autosomal. Okay, and you are going to complete 9 through the end for me. I'm just going to get some extra practice. There's an ed puzzle after this that you're going to watch, dealing with pedigrees, just to make sure you hear it one more time. We have a test this Friday, and you will be able to use a note page or a study guide, whether it be a piece of notebook paper or a piece of computer paper, front and back, that you can write your trends or anything like that to kind of help you. And from there, you'll be able to use it on our 15-question multiple choice test on Friday. Hope this helps, and have a great rest of the day.